So, when we're talking about heat, we are talking about the energy transferred between objects because of a difference in temperatures. We're talking about a formula which is Q equals CPm delta T. Now, the Q in this equation stands for heat energy, which will be measured in joules. So if you see something in a problem, and the problem is referring to heat, and you see joules, that's Q. If you see joules per kilogram degrees Celsius, that is specific heat capacity. Now, specific heat capacity is basically how much energy it takes per kilogram of a substance to heat up a certain amount. Basically, it's how hard is it to heat something up. That is a specific heat capacity. Something with a high specific heat capacity doesn't heat up very quickly. Something with a low specific heat capacity, the temperature just goes straight up. M stands for mass, as usual, measured in kilograms, as usual. And delta T represents the change in temperature. Now, you might remember from what we said before that delta, that triangle right there, which is the Greek symbol delta, means change. So anything that you put after that, it's changing that. So T means temperature, so delta T means change in temperature. Next, we have thermal equilibrium. Now, usually when we have thermal equilibrium, that means that the energy gained for a substance is equal to the energy lost for the second substance. You may notice these letters from an equation that I gave you earlier, which is basically Q equals negative Q, which looks complicated when you first look at it, but if you really think about it, the energy cannot be created or destroyed. It's only going from one object to the other object. So unless you're adding heat or taking heat away from the system, the heat that's gained from one substance must have been lost by the other substance. Now, the way you can tell which side of the equation you're going to be on is the one that's heating up usually starts off at the lower temperature. That one is heating up, and that one will be on the left side of the equation, the energy gained for a substance. Whereas the other side, the hotter object, is the one that's losing the energy. If you're the hotter object, your energy is leaving from you to the other object, the cooler object. So the cooler object is the one that says is going to be on the left side, energy gained, and the warmer object is going to be on the right side for energy lost.